All right, ladies and gentlemen, day 2 of getting ready for this big Unit 4 polynomial test. The ones we just finished up, I got in here so you know what page we're on. We're going to be on page 72 here. So let me move down a little bit here as we are getting situated. So one thing I would be remiss if I did not mention was you have the ability to use your factoring help sheet on said unit test, which could come in handy in this case, because I notice in looking at this, I'm always looking to see if they have something in common first, right? And I mess around with it maybe on the calculator for a minute, I find out nothing in common. So then I go looking, and I notice that 3 there for a cube, and I pull out my handy-dandy help sheet, and I go, hey, wait a minute, 27 and 64 are on here. So 27 would be 3u, because there's a variable there, and 64 would be 4. If you haven't put your cube numbers above there, do that. Okay, have that extra help there. Then I also have help when I come over to the other side of my sheet. Well, isn't that a coincidence? It's almost the same problem. It's a difference of cubes. We have this form. If the form with the A's and B's confuses you, okay, make little labels for these. So then when it comes time to follow the pattern, here's my pattern. So A minus B, A squared, the 3 and the U, make sure we get to both, plus A times B, 3U times 4 would be 12U, make sure I don't go off the screen here, plus B squared. 4 squared is 16. As long as you get these two terms right when you break them down, it literally is substitution. Just saying. Keep it simple. Speaking of, you're like, oh, well, here's another one. Well, wait a minute, Hardy. 27's on the cube list, but 12 isn't. What gives? Did you do step 1 of factoring first? Is there something in common that divides out of both? Oh. Does 3 come out of both of those? Maybe? Let's see. Can we get a 3 out of there? So if we divide each of those by 3. Now the other thing I would hope you notice is you're looking at the cubes list. That's not the right list to be looking at anyway. This is a square. So I get my squares list. Well, it wasn't on the squares list before either, though. So what we've got to check as we're going here now is, with it being a square, 2, do the same thing I did on my other one. So again, 4 would be 2, 9 would be 3. Difference of squares. A plus B, A minus B. Don't forget the 3 that you took out. But from there, so 2v plus 3, 2v, whoa, pens are flying, minus 3. Again, once I find the values, if you want to put a little a and a little b next to them, you can, but it's straight up, oh, I think my head's in the way. Okay, let's get my head out of the way. It's just going to be straight substitution. So again, be on the lookout, because when you're in these special cases, you may have to take a common factor out. Hardy, you're not doing it twice in a row, are you? Maybe. So when you're doing this, again, try dividing numbers in that you think may work. Maybe you go to your multiplication chart and you go looking around. Now this one's a little trickier. 125 and 20. Oh dear. Can't even fit it in my screen here. There's 20. Here's 125 over here. So if I follow that all the way over, I end up at 5. So that's a way you could do it. And then we divide our coefficients by 5. And here we go again. Same idea that we had here a minute ago. What do I square to get each of these? 2v Yeah, it's what happens when I do stuff between classes. Oh, got my head in the way again. Come on. So here, move that up so I don't have that problem again. Same pattern that we had just right up above. First plus second. First minus second. Okay. So always see if that common term is there first. It may not be every time, but sometimes it will be. Just saying. All right, we head to the next part. Find the inverse of the function. Switch x and y and solve for y. Okay, first thing we gotta get out of the way here. Anything of x is just a fancy way of saying y equals. Okay? Once we get that out of the way, we're gonna switch x and y. And now our goal is to solve for y. So first issue, let's get rid of the fraction. Let's get it out of the way. What's the opposite of dividing by 6? Okay, multiplying by 6. Get that out of there. Okay, that made life a little easier. Notice I didn't distribute the 6 on the right. That 6 just got rid of the fraction. Next goal, get the 5y alone. Okay, do the opposite. Now, little details. This has x, this doesn't. Don't put them together. It's not 11x. Last step, opposite of multiply by 5. Once that's there, you're done. Okay? That's the same way you're going to treat it on 34 or 36. I'm going to get you a start on 34, but I'm not going to take it the whole distance here. So here, we switch x and y. Now, strictly a Mr. H opinion. There is another way, but I'm not going to do one of my infamous, here's 3 different ways to do this. If the fraction is stuck straight to your variable, oh dear. I didn't do that, that's really a y. Yep, you don't see that. I would get the 3 out of there first, if it's written this way instead of one big fraction. If you want at this point, you could multiply by the reciprocal. If I just freaked you out by using a word like that, here's what we're going to do instead. How do I get rid of a fraction? The same way I did here. You multiply by whatever is in the denominator. So, in this case, we would multiply both sides by 4. And distribute on the left side. And then finally, we would divide by 5. So slightly different depending on the way it looks, but you know, still nothing too terrible. You ready for some good news? Thought you would be. 37 through 39. We didn't get in depth into proving functions to be inverses, so just not on test. Don't worry your little brains about it. Well, I'm not saying your brains are little, but just don't worry about it. I don't know where that came from. Okay. Find the inverse, then graph both the function and the inverse. Okay, this one I'm only going to do one. So here, still y equals. So job number 1, switch x and y. I'm going to change colors here. Solve for y. You're like, well, that's easy. Hardy, why you get the easy one? Hey, it's got to happen every once in a while. Okay. So we're going to do that one in red. We're going to do this one in, what's that, aqua? Sure. When you're graphing, and I'm going to do each of my lines one different way with this, so you have choices, okay? One way I can do it is if I'm comfortable with graphing and slope-intercept, which both of these are, I can just go to my y-intercept, the number on the end, and then from there I can do slope. Up 1 and over 1, up 1 and over 1. Or if I wanted to do the opposite, instead of up and right, I can go down and left, down and left. And again, I don't have to go crazy with the numbers. I can do as many as I'd like. If you're not comfortable with graphing, go to the y equals. I'm going to do this for my red line. Type in the equation you have. and literally pull up the chart and just plot some of the numbers, wherever you want to start. And again, you don't have to have a bajillion dots, just some, and go about your business. Okay? So you're always going to have the choice of typing them into the calculator or doing slope-intercept, or we did one more of these too. Let's say my initial line here, I had that. I'm just going to jot down some of those points. So like -2, 1, -1, 2, 0, 3. I'm just going to take these first 3 points. I could have made this line just by swapping let's check this out. 1, -2, 2, -1, 3, 0. I'd add those 3 points, wham, right through there. Okay, slope intercept, calculator, just flop your points of the first line that you graph. Okay? You got this. You got this. All right. Is the given binomial a factor of the polynomial? Use synthetic division to prove it. Okay. So whatever's after the semicolon, that's my divisor. But notice, you're like, ooh, Hardy, that's like sneaky. It's a set of parentheses. So when it's the set of parentheses, remember, you switch the sign. If it was just x equals, we'd keep whatever's there. But this, opposite of -5 is 5. Other caution, watch for degree gaps. How's that work again? You should be able to count from the first exponent down by ones until you get to 0. So at 3, it should go 3, 2, 1, 0. 0 meaning it's just a constant, it's just a number. So here, 3, 1, uh-oh. There's no x squared. I've got to put a 0 in for that, or this is going to be jacked up. Okay? So here, my coefficient of my x cubed is 1, 0, -21, -20. 3, 2, 1, 0 with my degrees. Once I got that set, and you won't have to have a 0 every time. Sometimes they'll be nice, like 44. Pull the first term down. Multiply by what's in the box. Put that in the next slot. And add down. Multiply by what's in the box. 5 times 5 is 25. Add down. 4 times 5 is 20. And add down. So, Hardy, what did I do? Did I do anything right here? Did something go good? Well, is a given polynomial a factor of the binomial? Is the remainder 0? Is the last number you get when you do synthetic division 0? If the answer is yes, the answer is yes. Okay? If it's anything besides 0, the answer is no. So let's play with one more. Change your sign. 4, 3, 2, 1. Oh, no 0. That's sneaky right there. That's sneaky. And I leave you two the nice ones. Why do I have to do all the bad ones? Okay. 3, 2, 1, 0. Pull the first term down. And here we go. Multiply. And add down. Multiply. Yeah, the nice thing about a video is you can pause me if I get too excited and going quick here. Multiply. And add down. Multiply. And add down. That, the last time I checked, is not 0. No. Anything besides 0 is no. Period. End of statement. Okay. Oh, what else we got? Hey, more good news coming. I personally did not end up discussing increasing, decreasing with you ever. Whole page. You're like, sweet. All right, divide, use synthetic division. Hardy, we just did this. Well, I'm going to do 1 with you here, just because we don't want to do overkill, but we do want to, make sure we're good. So, well, I'll do 51. I'm doing the odds, right? Switch my sign. Any gaps? 3, 2, 1, 0. Nope. Pull the first term down. You know the drill at this point. I know you do. 2 times 19 is 18. Add down, multiply. Add down, multiply. Whoops. Almost had a color issue there. Add down. Now this time we're not just looking for the remainder. Okay? This time we have to go back and put the variables actually in this time. So, with that in mind, we are going to start 1 degree less. So we're going to start at b squared, 2, 1, 0. And if there's a number left here, that's my remainder. And we're in business. Okay? So again, not too bad. Not too bad. Okay. Oh dear. It had to come at some point. Okay? Since we're not going to do a ton of these, I'm not going to require a ton of them on the test. We're going to do one of these. Long division, I know. You have to be prepared for future down the road in math. So we're going to do this. We're going to fight through. It's one problem. It's okay. You're like, oh, Hardy. Okay. Long division. Here we go. Nothing to shortcut here. Okay, so Hardy, how does this work again? All right, I would suggest, doing a little side work here. We are going to take our first term here, 6a to the third, and we're going to divide it by the first term outside. Not the whole thing, just the first term, a to the first. So 3 minus 1 is 2. That answer goes right here. Once I have that answer, we're going to take that answer, we're going to multiply it by the divisor, distribute this through, and here was the funky part from when this was originally taught. Normally when you're doing long division, you'd put this over underneath here and you'd subtract the whole thing. But I've found over the years that students tend to forget that both terms are being subtracted. So here's my suggestion. Whatever answer you get here, we're going to switch the signs on both of them. So switch the signs on both, and now I can just add down. The first terms cancel. 15 minus 12 is 3a squared, and I bring the other stuff down. And the process, gulp, starts over again. Hardy, how many times am I going to have to do this till I run out of a's? First term divided by first term. We're building our answer. Even if you only got through a couple of steps and said, oh, screw it, I'm done. For each one you get through, you're getting points. So fight it, fight it, fight it. Get through there. So 3a times a plus 2, a little distributing. Switch your signs. First one's canceled. 11 minus 6 is 5a. You're like, oh, already. Last one, I promise. Last one. Last one, pain will be over. 5a divided by a. A's cancel. Woohoo. Multiply the 5 through. If this is driving you crazy, might I suggest somewhere off to the corner on your note card, you at least just put an example of what the 2 steps would be to remind yourself? So what if I have something left? Okay, I can't divide -1 by a. There are no a's left. You said when we're done with a's, we're done. We are. So that -1 is my remainder. Oof, da hardy. I like synthetic division a lot better. So do I. So do I. And ladies and gentlemen, that's it. So as you're making your help card, okay, again, half a sheet of paper. If you missed either of the days and somehow didn't get one, you can still build one. Try not to jam it so full of stuff that you can't find what you need. Find the basics that you need and go from there, okay? I know if you put the time in that you've done some of the evens and that you've done this, you're going to do a good job, okay? Redemption's going to be good for you. But you've got to put in the time. I can't say that enough. So hopefully you're ready and raring to go for part 1 tomorrow. See you then.